Good morning or afternoon or evening. It's morning for me, nice and early Texas time. Michael, it is, I think, in the afternoon sometime for you, right?
Correct. 3 p.m. in
Yes,
Germany.
3 p.m. All right, so nice early afternoon then for you. Uh, I don't even think most of the people in the US are awake right now. We have generally a lot of people on the Pacific coast, which is 2 hours behind me. It's 8 a.m. for me, so it's 6 a.m. Over there. It's 5 a.m. in Alaska. It's 2 a.m. in Hawaii. You learn a lot about time zones when you run a global community. As I'm sure you know, you deal with people all over the world all the time. But
Yes, I do. And
thank
I just wanted to
yeah,
say
thank
hello
you.
to the people watching the
Yeah.
recording in the Pacific time zone later.
Yes, yes, thank you for joining us on demand. So we're here today to talk about EventBridge API destinations. And I hesitated there for a second because I always forget. Is it Amazon EventBridge or AWS EventBridge? It's Amazon EventBridge, right?
Correct, it's Amazon. Yeah, I had the
Amazon
same
EventBridge.
problem. Which one is it?
Okay. So I am Alan Helton. I'm an ecosystem engineer for Momento. Everyone watching this probably already knows me. You see me every week. And I'm joined today by Michael Gash. You are a product manager for EventBridge at AWS. Product, that's what the P in PM stands for.
Correct. That's the product.
Yes. Perfect. So thank you for joining us today. Now I know EventBridge has a handful of PMs. And they're all over different sections of EventBridge. EventBridge has, over the past few years, really just blown up in terms of functionality and almost mini products inside of what it does.
Right.
So, Michael, what specifically are you over inside of EventBridge?
Yeah, absolutely. So EventBridge started as this single feature or single service, if you will, right? But then over time, as you said, emerged into a set of capabilities and services. So these days, we talk more about EventBridge as a framework or primitives for building event-driven architectures. And my role in EventBridge in the team is to take care of API destinations, obviously, and also our integrations with containers, open source technologies like Kafka. I'm also part of the Cloud Events organization. So open source in general is kind of dear to my heart. And prior to AWS, I worked a lot with Kubernetes and Kafka. So that's still why I'm keeping an eye on that one.
Nice, very good. So I'm excited to hear what you have to talk with us today about. I know we're going to be talking about event-driven architectures, which has also skyrocketed in at least buzz lately. People have been doing it for a long time, since before I was born. And lately, I would say in the past couple of years, it's just been a hot topic. I think it's greatly increasing adoption rate, and people are really starting to understand a lot of the nuance of it and getting those best practices around distributed systems and handling async communications a little bit better. So I'm going to bring up your slides so we can just roll into it because I'm excited. I want to get into some deep conversation today.
Me
So
too.
I'm
Yeah.
gonna just
And
kick it over to you.
thank you. And I'm also excited about your demo later. So this is just going to be a handful of slides to cover some of the basics of event-driven architectures and EventBridge. So for anyone who's not familiar with this architecture and EventBridge, so you get a good baseline, and then Alan will take it off and do the rockstar demo. So let's head over here. Cool. So why are we seeing customers and organizations adopting event-driven architectures? And here we kind of frame it or summarize it in kind of three buckets. One is customers use it to accelerate their modernization of like existing applications and building new applications in the cloud. And event-driven architectures are a good architectural pattern to like kick off and also, again, innovate with higher speed by decoupling teams and making teams more autonomous. With that, the organizations have more agility to quickly respond to changes because the applications are not too tightly coupled anymore. They're kind of individual, if you want to call them microservices, smaller pieces that can evolve and innovate at their own speeds. And behind the scenes, this fabric, this event-driven architecture kind of meshes these kind of things together, as we'll see later in the demo as well. And then it is a way to enable building like near real-time applications. Typically what you've done probably is writing some code that pulls an API or runs a batch operation every 24 hours. Event-driven architectures kind of flip it on its head, that instead of you asking for information, the information comes to you. Almost like on television when you turn on the TV, like the stream of information coming to you, and you just step through the stream of information that you want to consume. And there's this difference between other architectural styles like REST, HTTP request-based architecture styles, which mainly use commands, basically intents to coordinate between services. And we're not saying event-driven architectures are making this obsolete. In fact, it's a duality. It's like basically a mix of often request response architectures and event-driven architectures that you would use, or in more general message-based architectures for asynchronous communication between components. So instead of directing commands or intent between applications or organizations, in event-driven architectures, we use events. Events are immutable facts that a producer of events, like a order service or payment service, or even telemetry from IoT devices or click streams and so on, emit. And then there's consumers which observe the events if they are interested in them, without the actual producers knowing that there are observers or consumers on the other side. So there's this decoupling coming in. And so we move from a synchronous architecture where you have two or more individual services, clients, components, however you want to call it, interacting with each other and waiting for responses in a blocking manner. We're moving into an asynchronous world where, as I said, particular services emit events through an intermediary, which is typically called an event broker or event bus, which could be like EventBridge or a Momento topic or any other like technology. It's not like this pattern is not specific to a particular service there. And then on the right-hand side, you have the consumers, and there's different models of consuming events. Sometimes it's a push-based model like EventBridge. Sometimes it's a pull-based model where the consumers pull the broker or the bus for information. Both have their own pros and cons, and you can mix and match as needed. And the broker in the middle has obviously routing capabilities. So it knows where to send information. Often there's filtering capabilities to only match on particular events, or event transformation capabilities to shape the incoming event into a specific event or type that the consumer wants to consume. And so EventBridge, as Alan initially said, over time evolved into a set of services or primitives for building event-driven applications. And today we are focusing on a particular feature in EventBridge, which has API destinations. And API destinations is available in EventBridge event buses, EventBridge pipes. Pipes is point-to-point connectivity, and not yet available in EventBridge Scheduler. Scheduler is a service that allows you to schedule tasks or trigger notifications on demand or periodically. So today we're going to talk about API destinations, and API destinations is available in EventBridge event buses and pipes. Scheduler on this slide is just for completeness in terms of the services available. And then when it comes to EventBridge event buses or pipes, we often have event sources on the left. Event sources can be AWS services, for example, S3, where you have an upload event, an object being uploaded or deleted, or a bucket being created, or you have CloudTrail events, which I think is really interesting and probably the demo also like part of the demo today. But you can also produce or send your own custom events and receive events from third-party applications. And then on the right-hand side, and this is where it now gets really interesting, there's different targets where EventBridge can deliver events. And one specific target, and also very popular target, is what we call API destinations. API destinations is a feature, like a mini service, as Alan said, as part of EventBridge, that integrates with HTTPS-based APIs. Often we call them webhooks or event handlers or remote event handlers. It's basically an HTTP client, if you will, that sends events to an HTTP server on the right-hand side. And recently we added, together with Momento, we added Momento as an integration a API destination partner integration. In general, API destinations can target any HTTP endpoint, but these partner integrations make it easier for you to set this up, and Ellen will show this in the demo later as well. One thing I want to highlight here on this slide is we have also cloud events. This is this little blue icon here, the E and the blue cloud. API destinations is fully cloud events compliant. So if you have a HTTP server, a webhook, or a receiver that requires cloud events, whether it's binary or structured encoding, API destinations can transform events basically to match the cloud event standard, which is pretty neat. And then digging a little bit deeper into API destinations, in fact, it consists of two components that you as a developer are using, which is the connection and the API destination. So there's a little bit of redundancy here, and that's sometimes mixed up. But internally, the connection is the way to express authorization to your endpoint. So for example, it allows you to specify basic username, password. We have OAuth support, or just token API key based. Connections can be shared across API destinations, and API destinations are basically the HTTP targets that you want to connect to. Like you specify an HTTP endpoint, the method, some headers, and the timeout today in API destinations is 5 seconds. And so together, API destinations, the API destinations resource and the connection resource form this unit of requests or this producer of requests, the HTTP targets. And you can reuse, obviously, connections across your API destinations. We offer integrated error handling with API destinations. So we have retries. By default, they're up to retried up to 24 hours and or 185 times. Basically depends on which one hits first, but you can configure and completely disable retries if you want to. And if retries are exhausted, we have the option to specify a dead letter queue, like in Amazon SQS dead letter queue, where we store information, metadata information, why the delivery has failed. So typically recommend setting up an SQS queue as part of your API destination, just to catch any errors and be able to replay these events. And then how do these events actually get to your target? And EventBridge has a concept of a rule. Again, you'll see this in the demo, so I'm going through this here a bit quicker. But a rule is the filter. It's the pattern match that matches incoming events to the target that is configured, for example, API destination. So here on the left-hand side, you see a regular event in EventBridge. It has a detail type, it has a source, other specific information, payload information. And if you wanted to match this event and send it to API destinations, for example, based on the source, you would create a rule. A rule is a JSON structure that matches on all the keys and values that you specify as part of the rule. So on the right-hand side, we see a rule matching on the key source, and an array, because you can match on multiple values. That's why it's an array in this case, an array of strings that are basically validated against the event. So in this case, we match on a single value in this array, which is com.orders. Rules are very powerful, and the rules engine in EventBridge is in fact open source. It's called Ruler, AWS Ruler. If you look at GitHub, you will find the source code of this library that we use internally as well. And Ruler has advanced rules, like obviously we can do primitive pattern matching here, but we also have prefix matches, wildcard matches, numeric matches, if not exists matches, and so on. So you can go pretty complex with these rule and pattern matches. And since we're going to share the slides probably and the links, I have some links in here how to get started with the API destinations. Also a shout out to our friends from the Step Functions team at AWS, because Step Functions integrates with EventBridge here as well. Step Functions is a workflow orchestrator, which also allows you to call third-party HTTP endpoints. And for authorization, Step Functions uses the AWS EventBridge connection resource. So we have kind of consistency here when it comes to calling third-party APIs, where you can actually share these resources like EventBridge resources between Step Functions and EventBridge. Also, that's all I had for the slides, and I'm excited about the demo. Alan, take it over.
Okay, great. And I'm actually really glad that you called out the Step Functions HTTP endpoints there at the end, because that is part of the demo. So I'm excited for
fantastic.
that because yes, if anybody knows anything about the demos that I build, it usually is two things that are consistent with almost every single one that I ever give. One, the resources that I create are built using a SAM template. So please don't haze me on that one. I know everybody likes CDK. I don't. I like SAM. And the other thing that is consistent is that I pretty much always use step functions. That's to me, it's a fantastic workflow orchestration tool that simplifies complex workflows and gives you really good observability as well, which is really what I mainly use it for. You can see exactly what happened at a glance, and it's easy. It's beautiful for demos because I can just toss up a workflow diagram instead of walking through code and explain exactly what's going on, which is what we're going to do today. So I'm going to bring up the demo itself first, and I'm going to actually use the demo, and then we'll go through what is actually happening behind the scenes. Before I do that, this demo is, I know it's not showing yet. This demo is using API destinations both ways that are available. So via a pipe and also via a rule and using it as a target. And then we are also using what Michael alluded to, where we are using the step functions HTTP integration as well. So we're using API destinations pretty much every way that we can in this demo.
Fantastic. And I did not.
Yeah.
I just have. Sorry, I just have one comment. And I did not talk about one of the key cool use cases that we had in mind with Memento when we basically both partnered with. Are you going to cover this one as well?
I don't know. Why don't you tell me, and then I'll tell you if I cover it.
Yeah. So since you brought up pipes, this point-to-point connectivity, pipes supports, for example, DynamoDB streams as a source, right? So you can subscribe to update, delete, or inserts operations of a DynamoDB table and put that through a pipe. And the pipe with, as you said, API destinations sending to an HTTP target can now be used to update or invalidate caches. And I guess you have a product there. So that was like really exciting once when we first met and we kind of spoke about some of the ideas here. And I like, this is really exciting. I don't know if you show it, so that's why I want to call it out.
Yes, we will go over that today.
Okay, cool. Awesome.
So one more pre-word before I actually show the demo. I am intentionally going to be demoing something that's more than a CRUD or a Hello World app, because we've seen those. We've seen your basic to-do lists, and while they are helpful in illustrating the concepts, it leaves a little bit to be desired when it comes to what can I actually build with this, because the majority of things that we're building out there that are in production are not to-do lists. They are things that have async communication, that have distributed systems backing them, multiple microservices. So today I am not doing a basic example. It is going to be a little bit more involved intentionally. And so with that comes a little bit more words for me, but hopefully you guys are okay with that. So let me bring up the demo. Let's take a look at what I made. So you can see on the screen here, I have a game, a fun little game. It's just called Catch the Squirrel, and the squirrel is moving around every 2 seconds ish to a different spot on the screen. And really, the whole objective here is for me to click on the squirrel. That's literally it. And when I click on the squirrel, I get experience points. And when I hit a certain number of experience points, I grow levels. Let me actually refresh, because I think I had this up too long that some of my connections timed out. So let's do that. Okay, so I'm gonna start clicking the squirrel. And whenever I click the squirrel, this is firing off some async calls to the back end. And you can see over here, my level just secretly went up to level 2. So I'm going to click on the scroll a few more times, watch the level, and we'll see that after I click a certain amount of times, there we go, I just went up to level 3. There's no pause in anything. This is all happening async and updating in real time as the processing occurs. Now the levels It's going to take me an increasing amount of clicks every time because the levels go up in powers of 2. And every time I click is just like a single point. So I think I have to click it like 8 times now. You can see I'm up to level 4. And that's really it for the demo. Like, well, I firmly believe a good architecture makes the user experience simple. So all I showed as far as the user experience is me clicking on a squirrel, and that's it. Again, a good architecture, to say it another way, is going to abstract the complexity for your users. Now, there's a lot going on behind the scenes. Like I already said, we're using API destinations a couple of different ways. We're using HTTP endpoints. We're using step functions. There's got to be a reason I'm using step functions because if I'm just doing one thing, there's no point in using step functions. So I'm doing a multi-step process here. But all I was doing is clicking a squirrel and watching this number go up. So there's a lot happening here behind the scenes. And let's go through a story diagram to actually talk about what's happening. So let's look at the screen one more time. You can see our URL here is, generic API gateway URL/game. Let's talk about how this is built. I'm going to bump over to my favorite diagramming tool, Excalidraw. And here's what's happening. So I run a get on /game. You saw that URL just now, and that's going to hit a Lambda function. So that goes through API gateway, and that API gateway routes over to a Lambda function. That Lambda function is going to communicate with the Memento API to give you a disposable token or a session token that is going to let you access Memento resources from the browser, from the client side. This is a limited scope token that only lives for a certain amount of time. So it's safe to pass down to the client or to the browser. It's also going to go and hit DynamoDB to load user information. So we are storing users by IP address because I'm not a huge fan of that in demos where you hit a page, you have to insert a username, create an account. That's too much. So right now we're just using IP address to assign users in our system. So we're loading that user. We're getting their username, we're getting their levels and their level, their XP, and then we are actually going to be generating HTML in Lambda and returning that HTML to the client. So we can see here that we are serving the HTML that the Lambda builds back down to you, and that's that game that we're seeing. That's what happens here. Now that game, there's actually a decent amount that's going on that you don't see in that game besides the squirrel moving. Now, obviously, there are pieces in play here that are client side and server side that are going on. Whenever this squirrel is moving around, that's actually being tracked by a location cache item. It stores the X and the Y coordinate, and it also stores the ID for the squirrel at a particular location at a particular time. And we do that because this is technically a multiplayer game, and only one person can get a squirrel, get credits for a squirrel if you click on it before it moves. We don't want everybody getting it and getting points for it. So whenever the squirrel moves, we update that location and from the client side, and we can access it on the server side. Let me scroll this down a little bit. We can actually see what's happening here. So we're doing two things. We're storing that location. We are saving it. We're basically generating it on the client side and saving it to our remote central location inside of Memento cache. So every 2 seconds, we're reassigning that location and it moves around on the screen. So when we do that on that 2-second timer, we save that in Memento cache. And this is over an HTTP connection. Because I generated the HTML in Lambda on the client side, this page is just HTML and JavaScript. So I don't have access to install a bunch of NPM packages that are compatible in the browser. I'm just doing vanilla HTML, vanilla JavaScript. And then, you saw me click on this a few times and the level went up. So what we're also doing is we are connecting to Memento topics via long polling and basically watching for level updates to take effect. Now, what's long polling? There are a few ways to do real-time notifications, And I'm going to put that in air quotes because there's a lot of confusion on real-time notifications. I could talk for an hour on that. We're not going to, but we are going to talk super high level on what some of the options are. Now, what everybody is familiar with when you think of real-time notifications is push notifications. Think WebSockets, think gRPC, think server-side events. So that's something that happens on the server side, and you are actively pushing that down to a connected client. Now, that requires a persistent connection, which means I connect up to the sky, and that is always open, kind of like a phone call. And when something happens, it just sends that message down over the phone call. But because we're in plain HTML and JavaScript, we don't really have an option to do that. So what instead we're going to be doing is long polling. Now, when people hear polling, they think of short polling typically. And now what a short poll is it is sending an HTTP request over a fixed amount of time to say, do you have anything? And the server will say no, or it will say, yes, I do have something. And let's just say that you're doing a short poll every 2 seconds. Do you have something? No. Do you have something? No. Do you have something? No. It's really chatty unnecessarily. You're making a whole bunch of different calls because you're trying to, get information as soon as it comes in. But the big drawback on that is A, you're wasting bandwidth, and B, you typically are going to be losing some of that precision with real-time notifications because, at worst, you're going to get that full interval of time difference in when data is actually available. So let's say you do, is anything available? No. Let's say immediately there is data available, but you're waiting 5 seconds to call it again. So now you're going to wait 5 seconds, and then you're going to get that data this next time you do is something available. Now the difference with long polling versus short polling is that the server is not going to respond until there is data. So you can say, do I have something? And then the server's going to say, wait, yes. And it's going to pass that down, and you're going to process that. At which point you would then immediately hit that endpoint again and basically wait until there's data available. So that's what we're doing in the client side here in this app is we are long polling Memento topics via just an HTTP request to say, hey, give me an update as soon as you have one on the user level. You can see that over here. Whenever the user level changes, I want to know so I can go and update the user interface. And we saw that. We saw me progress from level 1 to 2 to 3 to 4. Now, also what happens is an actual a regular request response whenever I click that squirrel. So when I click the squirrel, it will hit an HTTP endpoint that I have an API gateway that does a post to the dash squirrels endpoint. And what that's going to do is inside of API gateway, it proxies directly to step functions. No Lambda here. Yay. It's connected directly, and it's basically starting an async execution. So what that's going to do is it's going to say, hey, give me the squirrel ID. I already have your IP address, so I'm going to pass that on to step functions and then give you a thumbs up and let the game resume so we don't have any lag whenever you click on that squirrel. It's just going to keep moving around and let you continue playing while it handles all the heavy processing on the back end. Cool. So let's continue from there. Now that step function workflow does a lot, and we're gonna process this here one by one. So the first thing that it's gonna do is it's gonna check Memento cache, but it needs to do that synchronously. And I don't want to use a Lambda function. If I can get away with not using a Lambda function, I will. So we're using the HTTP direct integrations inside of step functions to communicate with Memento cache. So basically it's saying, hey, go fetch me the current location of the squirrel. Because again, we're doing an item potency check. We're saying, has this already been processed? And also, is it the current one? So I don't want people spamming requests to our endpoint on an old location. So it's saying, hey, get me the current squirrel location, and it's doing an item potency check. If it doesn't exist, let's just say that it's not in the cache for whatever reason, we'll just set a default and publish event. We'll go over here in a second. So it says, yes, I do have the location of the squirrel. Is the ID of the squirrel that was clicked the current one? It's basically all we're doing here. If it's not, we'll say, okay, we don't need to process this. This is old. You're not going to get credit for something that happened in the past. Now, in If it is the correct squirrel, we're going to do a few more things. Now, I start a parallel state here because we actually have more than one thing to do if that is successful. The first thing is we got to set the squirrel to a new location. So I don't want somebody spamming that squirrel for 2 seconds. I want it to change immediately if I click it. So what we're doing here is we're saying, okay, well, let's just get a new random location and then publish that out to, excuse me, to the game. And what we're doing here is we're calling the cache synchronously because I don't want to proceed until the cache is updated because that's where the game is fetching that information from. And then we're using API destinations to call Memento topics asynchronously to then actually push that down to everybody that's connected. So what that's going to say is, hey, I have a new location for the squirrel. Please go update yourself. And the game will pick up on that via that long poll and proceed. So that's this arm. And again, we're going to go into this put events in a second, what that actually does. But that is an API destination via a rule. So the rule is targeting the API destination. Okay, let's talk about what happens again for the other thing when you click a squirrel. So this is what actually happens to track player analytics. So what we're going to be doing here is we've already pulled the location of the squirrel out of the cache. Now we're going to pull you out of the cache. We're going to pull your user. We're basically going to make sure that you exist. We're going to pull your current XP, and we're going to pull your current level out of the cache. So we're going to look in the cache to see if you exist there. If you don't, we'll fall back and load you from the database. Now, really the whole point of this check is to take load off of DynamoDB. It's a little bit cheaper to call the cache than it is DynamoDB. So let's just say, yes, you are in the cache. You have been playing this game, so you're hot loaded. We fall back down here and we are using Lambda. I couldn't get away with not using Lambda in this case. But what we're going to be doing is basically adding 2 points to your XP, and then we're going to be calculating your total XP to see, did you grow a level? I had to do a little bit of complex math, or at least more complex math than you can do in intrinsic functions inside of step functions for that. So what this is going to do, it's going to add that level, and it's going to add that XP, and then it's going to save it to DynamoDB. And you see we have a little arrow here. Let's follow this arrow. What does that do? Okay, so inside of this Lambda function, we're saving your user record into DynamoDB. That is going to trigger a DynamoDB stream. And that DynamoDB stream is connected directly to an EventBridge pipe. No Lambda function involved here. And that pipe is going to target the API destination for a cache put, which means we're just going to overwrite the data that's in the cache with the data that is coming directly from DynamoDB, our source of truth, technically. So what that's going to do for us is whenever we make a change inside of DynamoDB for this player, we can have it automatically updated or invalidated in the cache. So it is hot all the time. This happens in milliseconds. So this pattern here that we're talking about is called a write aside cache. So we're writing to the database and then it is subsequently being written to the cache. That way it's always hot when you're making changes. Now you see here, this is something that Michael didn't talk about that I actually really, really like about EventBridge, specifically with the API destinations and the connections, is you need an API key to communicate with Memento. You need that with every service that you use. It's secure. It's how we can identify your accounts, how we can identify your specific resources. When you create a connection inside of EventBridge, it will save your API key, if that's the authentication method that you're using, inside of Secrets Manager. But here's the cool part. It saves it for free. Now, normally, Secrets Manager is going to cost you $1 a month for one secret, and then you also have to pay every time it gets called. You don't have to when it's in API destinations. This is actually managed for you for free, which is a really nice way to get around that extra cost, especially if you're on hobby scale like I usually am. I don't like that extra dollar to be a little bit secure when I'm just building hobby projects. So anyway, let me dial this all the way back. So we've updated our user and we have saved their new level and we've saved their new XP into the database, which subsequently gets saved into our cache. And then we can decide that this lambda function will say, did the user level up or not? So it says yes. And then we will call a synchronous publish to Memento topics, which we don't have to. I was just doing this to show that you could. In fact, I don't actually recommend doing it this way. I do recommend calling it async. But again, to show that you can, we are calling the HTTP publish synchronously via HTTP endpoint in step functions to then pass that down to the game to increment that level. So I went from 1 to 2, 2 to 3. And all I'm doing is I'm passing in the IP address and the new level, so the game or the client can pull that out of the DOM and update it. And then we're done. So let's talk again one more time about the other way that we're using API destinations via EventBridge, and that's via a rule. So whenever we're updating this location, we are calling put events on EventBridge, and we have rules that are configured on our EventBridge default bus that says, hey, whenever you see topic publish as the detail type, the event name, basically, if you will, let's go ahead and route that to an API destination. Follows the same exact thing, right? This is in fact the same connection that we were using on the other side, where I've stored my API key secretly inside of Secrets Manager, and it is storing that for me and then passing that along to Memento topics. And this is the way I would actually recommend doing this most of the time, because this is fully async. You don't need to call a publish synchronously because it's being delivered asynchronously. So it doesn't really make sense to do the publish synchronously unless you're specifically watching for publish errors. This is going to say, okay, fire and forget. Let's pass that message down to the client and be good. So this is rules. And the other way that we were talking about is via a pipe, which basically is a hard-coded thing that I have in my infrastructure as code to say, okay, from a stream, go target this. This is a little bit different. So I think that might be the end of my whiteboard. Yeah. So that's the end of my whiteboard. Now, this is super cool. And let's look at what actually happened. So let's look at an actual execution of the state machine. So I can prove to you this is not all smoke and mirrors. I like the theory, but let's do the practice. I'm a builder, and I, just like you, am skeptical of people that come in and show things that feel too good to be true. So you can see September 26th, 8:20 a.m. That is when I was going and using the game. So let's click on it. This is why I like step functions so much. I can see what happened, right? There's obviously all these steps, but I can go in here and see what happened on this specific invocation. So you can see I was a little bit late when the squirrel was on the screen. So what ended up happening here is when I'm doing this item potency check, I did not have, that's rough. It shouldn't have done that. But basically, the ID of the current squirrel needs to match the ID that was passed in from the event, and then we can continue processing. So let's look at one that did work. This one took 1 second. So this one is actually one that happened when I clicked on the squirrel, and consequently, I leveled up, which is super nice. So you can see in here, I pulled the data out of the cache. This ended up with the response body. So this is the value that was stored in the cache, X, Y, and the ID of the squirrel. Down here, we're checking, okay, the ID that was passed in via the post request was this. Is that the current squirrel? Yes, we're going to continue and actually do something. So we go in here, we calculate the next location. This is just doing math.random 1 through 10 2 times so we can get X and Y, and then we're publishing that. publishing that to EventBridge. So you can see this is the put events command, where we are sending the detail type of topic publish. That's going to trigger that rule that says, hey, whenever you see topic publish, call Memento, and put this inside of the body of the publish message. And then we load the player out of the cache because we're trying to avoid unnecessary database calls. We do have it in there. So you can see we did not traverse down the database route because it is hot in the cache. Here we go. Let me zoom in a little bit. Just realize that's hard to see. And you can see the output here is in fact the user information. Here's my IP address. Please don't use that maliciously. Here's the XP that I have. Here's the level, and here is the username. And then from there, we pass to the Lambda function. The Lambda function returns, did user level up? True. We hit that branch, and then we are once again going to be using the HTTP direct invocation to say, hey, the user leveled up. There we go. The user leveled up. We're going to post to /topics, wherever that is. We're going to use the connection that we created inside of EventBridge to actually, hold that authentication information for us. And then we're on our merry way. Super cool. It actually works. Yay. No smoke and mirrors. So this is, again, a little bit more complex than a normal CRUD application or to-do list intentionally, right? This is actually doing a whole bunch of different things. It's, asynchronously updating the cache in a write-aside pattern. It's fetching data out of the cache. It's falling back to the database if it's not in there. And then it's publishing multiple different types of messages as part of this workflow, both synchronously and asynchronously. Now, this is all great. And as a builder, probably one of the most frustrating things is seeing a demo like this and wanting to reproduce it myself and then being stuck on, well, dang, that was a lot of setup and I have no idea how to set it up myself. Well, thanks to the hard work of Michael's team, it's actually super easy. So if we go into EventBridge, you can set up a connection to Memento dirt simple. So this is the EventBridge. Let me zoom in a little bit more. This is the EventBridge console. I can click on connections down here. I already have it in here, but we're going to do a demo one here. I'm actually not going to go all the way through with it, but I'm just going to show you how easy it is to set up this connection to Memento to do these things. So I have demo down here for destination type. I'm going to click on partner. That brings me this combo box. I'm going to click on Memento, and it already knows, oh, you're using Memento. You're going to be using an API key. The API key name, what we're going to be putting in the header is authorization. And then this is where you would go in and type or paste your API key. From there, you can hit create, and you are connected. This is going to be stored at Secrets Manager secretly for you. It's hard to actually find. I think I had to ask Michael directly, where is this stored? And he told me Secrets Manager. And then you're good. The part 2 is setting up these rules and the actual API destinations themselves. Again, this is the connection. This is the thing that's managing your API key for you, that we know, whenever we want to hit Memento, we're going to use this API key. We're going to pass it in an authorization header, and we're going to go. There's several endpoints that we have in the HTTP API for Memento, but to save you some time, inside of the Memento docs, we have a quick launch that builds all of these for you. So every single one of our API endpoints, get, set, publish, subscribe, each one of those can be made as an API destination if you just click Launch Stack. So we've already done the hard work where you can basically just click that and it will deploy all of these API destinations for you with rules to trigger them. So all you have to do is topic publish and you're off to the races. That way you can come back to my example in the GitHub repo that everything I demoed is open source to GitHub. You can just come back to that, copy, paste into your account, probably change the ARN of the connection, and you're good. And it will just work. That's all you have to do. You don't have to go through this lengthy setup. You don't have to go through actually discovering how is it working under the covers. You can if you want. I understand engineers do that anyway, but for a time from idea to I can see it working in front of my screen, this takes about 1 minute to deploy, so you can get from here to there in like 3 minutes. So super nice. It goes through, exactly what you're doing in the documentation, so you're not deploying a mysterious stack into your account. Nobody likes doing that. So this has everything, how to use it, fun stuff. Whew. Okay. You can tell that I'm still, Michael, on my morning coffee. I feel like I said 5,000 words in however long that was, 30 minutes. I don't know. It felt like 2 minutes.
Yeah, probably 4 minutes for me. No, it was really good. I think because I haven't seen the demo, so I'm kind of your viewer as well here. To me, it was very like clear the way you described it. You not too overpaced. And what I really liked is that you showed not just one example, like the basic CRUD example, but that you can reuse the connection even between the step function and EventBridge if needed, or between the pipe and an event bus rule. And it's basically the same service or the same experience that you will see with a very high consistency between those. That was really nice.
Thank you. Thank you. And I really like the combination of Memento topics and EventBridge because, everything that I build is in AWS. Kind of comes with the AWS hero territory, right? That's kind of just what I do. But because of that, all the communications, all the async communications that I'm doing are in EventBridge. So, I'm always using that to connect all my different pieces. Maybe it's Lambda, maybe I'm pushing something directly into a queue. Who knows what it is? Maybe it's step functions, it's usually step functions. But because now we have API destinations that can connect to topics, what's really neat about Memento topics is that it can connect to the browsers directly. And that's not, that's something that technically you can do with EventBridge if you pass down credentials down to the browser. I wouldn't necessarily recommend that, but with Memento, totally could. You can really lock that down super, super tight and get that in there. And it, again, just works. So anything that I'm doing in the back end, let's say I'm doing a long processing job, I can periodically send out these status updates to say, yes, this is working, and get that to the client, to the actual browser, to show people that things are happening. In fact, I did that just over this past Christmas. I did a hackathon for Serverless Guru where I was streaming responses from Bedrock down to the client, where I was just publishing the little chunks that were being returned to me down to the client so people could actually see it is doing something. I'm not waiting 11 seconds or however long it takes to get a response from an LLM. So that extra connectivity between EventBridge and topics down to the client, to me, is just the best.
Yeah, and there's one use case that I hear
I lost
often.
your sound, Michael.
I
can't hear you anymore. But I don't see
really?
you on mute.
One sec. Test. I should be here. No?
Nope.
One sec. I can see my
This is the best part about doing things live, is even things that were working for the whole time. We've been live for 50-ish minutes. Now the microphone decides to cut out.
What about your speakers?
Maybe other people can hear you. I can't hear you. Maybe it's me. Maybe my headphones died. I don't know.
Yeah.
Let's see. Okay. We have people that can hear you. It is on me.
Test. Oh, it's on you. Oh, cool. Okay.
Well, let me switch then. We'll go. Let's see.
Cool. We have the typical split brain here network. Can you hear me?
There we go.
Test.
I can hear you now. It was on
this
me.
This time it wasn't.
Shame on me. That's what I get for trying to blame you.
Okay. Yeah, I saw the audio like going up, so I was like, why am I seeing this? Cool. And no, what I wanted to say, Alan, was that there's a cool use case that I heard. I don't know if customers have been implementing this with Memento topics, but Memento topics, because of the WebSocket, basically the integration with browsers, make it so neat. Makes it actually quite easy. we have in EventBridge, one of our most popular event sources is CloudTrail. All these security events or audit-related events that you get with EventBridge through CloudTrail. And last year, I think we released support for so-called non-mutating events, which are like CloudTrail events, which are get, list, describe events, like someone scanning your S3 buckets or someone listing your IAM users, for example, which could be scripts, could be bad code, polling versus you should be event-driven, but it also could be malicious, right? And in this case, what I heard some customers doing is that they stream that through API destinations to like a third-party API or into the browser, and to have like operators in their dashboards seeing like important events based on filters coming in. Obviously, you can also, or you should also like persist those like in CloudWatch or in another topic in this case. But having this real time in the browser to pop up like an alert to the operator, it's like super slick with browser-based integrations like topics.
Absolutely. And it's something that we're seeing more and more with user expectations for software these days is just, I expect to see things in real time. If you don't have that,
Yeah.
then you're bad. If you do have that, then it's kind of business as usual. It's just an expected behavior nowadays. So you're hard pressed to get by without that type of real time notification.
Right. No, that's certainly really cool. And you praised us for implementing the Momento integration in API destinations, which we did, but also kudos to your team, because the engagement and all the information that you provided was very top notch. So it wasn't too hard for us to implement this integration.
Well, thank you. Yes, the engineering team over here is pretty spectacular. And you probably know
Yes.
most of them. The majority of the engineering team at Momento did work at AWS for a decent amount of time. So they brought that distributed knowledge over here.
Yes, that's cool. Do we have
Well, all
questions in the
right.
chat?
Yeah. I didn't see any questions that popped up during the session, but if anybody has any questions right now, please go ahead and ask them. We'll answer to the best of our ability. If there are no questions, then I'm just going to kill time while people are typing their questions. If there are no questions, then we can wrap this up. This video is going to be live, or is going to be available on YouTube indefinitely on the Believe in Serverless channel. I think we're also streaming to the Momento one as well if you're looking for it there. It is there. We are streaming concurrently to LinkedIn, to Twitter, to Twitch, YouTube. It's all everywhere, but it's ephemeral on pretty much everywhere but YouTube. So if you are looking for this in the future, well, I guess if you found us and you found us on YouTube, if you're watching this on demand, but it is everywhere, just to make sure that nobody misses it. Okay, I didn't get any questions in the comments from any of the places that were streaming. Maybe that means we did a really good job, Michael. Maybe everybody is ready to go use API destinations with their favorite third-party software and just start integrating in their asynchronous workflows.
Yeah, and to be honest, it's pretty easy. So there's not much to talk about. So I really like that you had a more elaborative demo, because just talking about API destinations would have been a 2-minute serverless video today. So
yeah,
that was good.
Oh, cool. Yep. Thank you, Michael. Thank you, everybody that's watching.
Thanks.
It's a great time. I always love walking through demos, especially when it's something cool and asynchronous and something that communicates with the front end from the back end. So thank you again, and we will see you guys next time. Bye, everybody.
Bye-bye.